Alright, so 9.3, we're going to undo our differentiation and do some integration. Yes. Alright, so they give you this nice list, which you can sit and you can memorize. Yep, you got to be careful. So let's just kind of go through this just really fast. It makes sense, I hope, that the integral of cosine is sine. Okay, because the derivative of sine is cosine, right? That makes sense. Okay, and it makes sense, I hope, that the integral of sine is negative cosine. Negative cosine, careful there. Okay, and the last 6 of these are like literally undoing the last 4 of the other ones. Okay, so because they gave us for number 3, they said, oh, the tangent of x is secant squared, so we just can undo that. So that's not really new information to you. Okay, ditto on that, you just have to be really careful. Just remember the c's are negative. Okay, just like before. That's not different. This is the only one that you have to be careful of, the sine one. Okay, so remember the integral of sine is negative cosine. Yes, yes, exactly. So anytime you integrate, you always divide by it. If you're deriving, you multiply by the whole thing. Okay, so it's kind of like you're just throwing this all together. It's not really new information. It's just kind of connecting the dots for all of it. All right, so hopefully you noticed the two things that you would really use a lot. You got sine, you got cosine, but the ones that you don't really have are the tangent and the cotangent. Okay, so they're going to walk us through the integrals of tangent and cotangent, which is kind of interesting. So you guys remember that tangent is equivalent to sine over cosine, right? So we have sine over cosine. Okay, so what I can do is anytime I'm integrating a fraction, I should usually be thinking about rule number 14. You guys see this sheet that I gave to you from chapter 7? Okay, this is going to come back. This stuff is never going to go away. Okay, so if you don't have it with you, I'm going to write it down for you. This is the rule number 14. It looks like the integral of the derivative of u over the u is equal to the natural log of the absolute value of u plus the c. Okay, so if we take that idea with our sine over cosine, the bottom is the u. Okay, so we can say u is cosine of x, right? So what's the derivative of the cosine? Careful. Yeah, it's negative sine. Okay, so is negative sine exactly the same as the top? No, it's not exactly. So what do I have to do to make it exactly the same? Multiply by a negative. And if I multiply by a negative, I have to divide by a negative, which in the world of negatives, it's the same as multiplying by another negative. So I have a negative on the outside, a negative on the inside to undo it. Okay, so now I have the exact setup for my rule number 14. So what is the integral for this? Negative natural log of the absolute value of the cosine of x. Does everybody follow that? Okay, so you kind of have an option here. You can remember how to do that, or you could just remember the definition. Remember that the integral of tangent is the natural log of cosine. Well, it's not technically a U substitution. It's really like a rule number 14, but I wrote it that way so you can see the pieces that I broke it into.
How do you know which one to use?
The U comes from the bottom if you're using rule number 14. Okay, so let's do number 2. The cotangent is equivalent to what over what? Or cosine over sine? Okay, so if we did the u piece on this, okay, the u is the sine of x. What's the derivative of sine? cosine. So the u derivative is the cosine. So now I would look and say, is cosine of x exactly the same as the top? Yes. Okay, so in this scenario, I can go straight to my integral by using my rule number 14. So what is the integral of this? Natural log of the sine of x. Good there? Yes? Yeah. No? Maybe so? All right.
So you end up not really.
Oh, yeah. You mean the integral? You do it. Derivative of what? Sine?
You.
Yeah, you did. It's cosine. That's the top. It's very important. Well, it's because I did use it. It had to be the top in order for me to use rule number 14. So that's a rule number 14. Okay, so let's practice a couple more of these. Number 3, what is the integral of sine? Careful. The integral of sine is negative cosine. So we have negative cosine of x. Okay, so this could be simplified, and we can say negative negative makes a positive, so this would be 3 cosines of x. Okay, which rule is number 4? Okay, so we got an integral of cosine, but this time I have a pi in there, so I'm going to divide by the hook-on factor. Okay, so what's the integral of cosine? Sine, so it's going to be the sine of pi t. Okay, and then I divide by the derivative, so divided by pi. Go away. Plus c, yes. Okay, so you could write that as 1 over pi times the sine of pi t. No. Because the pi is in with the sine. Everybody good there? That was pretty easy. Okay, what about number 5? Which rule am I going to use for number 5? So we are thinking about all of our integration rules. Okay, we have like basic integration. We have general power rule. We have all of those rules that I wrote down on that sheet. Which rule is this? Product is a derivative rule. So you can't do product.
It's number 7.
Number 7 on the sheet? No. That says a to the x. The a would be some kind of constant number. So like, for example, if you had like 5 to the x, that's how you would use number 7. Okay, so what? Oh, yeah, if that was an x, maybe, yeah. So this rule is just going to be the general power rule. Okay, so this is the one where we're going to take that y squared and we're going to ignore it for a second, and we're going to integrate it and hope that it gets canceled out. Okay, if it doesn't cancel out, we have a problem, but if it does, then we can use that rule.
So you
divide
by
Divide by the derivative of the inside, yeah. Okay, so I'm going to integrate the secant squared. So what is the integral of secant squared? Tangent. So we have the tangent of y cubed. Now I have to divide by the derivative of y cubed. What's the derivative of y cubed? You meant 3y squared?
Yeah.
3y squared. So did the y squares cancel?
Yeah.
Yes. Okay, so if those cancel, you can go ahead and use that rule, that general power rule. So I would probably write this as 1/3 times the tangent of y cubed plus c. How come you guys are so talky today? Tuesday is your answer for that? Tuesday talky day. Yes. Because you kind of, it's like that was the hook-on factor. And so we're like undoing the hook-on factor and hoping that it cancels out. Okay, what about number 6? What is rule number 6? What do you think? Number 6. Number 6? Yeah, that's like literally rule number 5. Good eye. Okay, so I can just take that. So what is the integral of secant times tangent? Number 5 on lesson 9.3.
Oh, yeah, I'm looking at the other.
Oh, chapter 14, number 5. There's a lot of number 5s. Yeah, so this one is just the secant. Okay, and we have 2x plus 1, but since we have 2x plus 1, I have to divide by the derivative. What's the derivative of 2x plus 1? 2. What?
Good eye there.
Yeah, that makes that one way easier. If you identify those rules, life is easier. Okay, what about 7? Who's got an idea for number 7? Okay, so when I look at number 7, I see that there's a fraction. Okay, so I either start with rule number 14, or I know it's a U substitution. Okay, so let's start with looking at number 14. So can it be a rule number 14, first of all? I can look at that and tell you yes or no. Okay, if I take the bottom and I derive it, I see a sine squared. What's the derivative of sine squared? Well, it would be 2 cosine, and then you'd have to multiply by the derivative of 5x, so it'd be 10. So we could do it that way. Okay, so if I do it that way, I would have sine squared of 5x. So this is a chain rule, right? So I would have the outside, right? Yeah, you're going to notice it right away. So the outside sine of 5x times the derivative of the inside, which is cosine 5x times 5. Derivative of sine? No, derivative of cosine. So, oh yeah, thanks. So, is this exactly the same as the top? No. And can I make it turn into it? Okay, on this one, I cannot make this turn into it. Okay, so see how I have a sine with an x in it? I can't use this rule on this scenario. It cannot be exactly the same. Okay, so this is going to be a U substitution. I'm actually really close here, but my U is not going to be squared. It's just going to be straight up sine. Okay, so this is the scenario where, remember you guys did U substitution, and the U is always the piece that has the parentheses in it? Okay, this is U substitution. I know, because that's the part I'm going to rewrite. Okay, so U substitution, remember the U is always the piece that's inside the piece that has the exponent. Okay, so the piece that has the exponent in this case is the sine. Okay, so the U is just the sine of 5x. Okay, so I'm going to derive this. I'm going to write this a little bit different because I'm not going to use that notation of the rule number 14. I'm going to use my correct notation. What's the derivative of sine? Cosine, so it would be cosine of 5x, but what if I have 5x after cosine? Multiply by 5, I'm going to throw that in the front. Okay, so now if I look at this, is that exactly the same as the top, the other parts? Almost. What am I missing? 5. So if I multiply by 5, what do I have to do to undo that?
Well, isn't
Right.
there a U squared?
Okay, so when I rewrite this, yes, now we're going to rewrite it. Okay, I'm going to have a 1/5. Okay, so do you see how the top 5 cosine of 5x dx, oh, I forgot to write this on my thing, dx, is going to replace the whole top. So this is technically going to become a du. And then my bottom is going to be u squared. Okay, now I don't like the way that's written. I don't want the du to be on the top because I can't integrate right there. What's that? Because the bottom is sine squared. Okay, I should technically write this as 1 over u squared, and if maybe that was too slow for you, maybe you already have this written as u to the negative 2 du. Okay, so now I can do a basic integration. I have u to the negative 2. This is where I add 1 and divide by it. So if I add 1 and divide by it, what is my new integral? What's negative 2 plus 1? Okay, so I'm just going to do it this way, but yes, what you said was fine. Okay, so I just my basic integration. Can I do 2 steps in 1 here and simplify and also plug my u back in? Okay, so you guys see how I have a negative on the bottom, right? So I'm going to pull the negative out front, so I have negative. And then since my u has a negative exponent, I'm just going to write it on the bottom. So I have 5 times the sine of 5x. How do we do on that? How did I get from u to the negative 2? Wait, which one? Oh, that's your basic integration. So I integrated it. So remember when you do an integral, you add 1 to the exponent and divide by that number. So that's what that is. By the way, what's another way this might be written on a multiple choice question if I have a sine in the bottom? Times a cosecant, right? So it could be written as negative 1/5 times a cosecant of 5x. They might play with that and rewrite it. So you might get to the final end and be like, oh, what? I don't have anything close to that on the multiple choice, but they might play with those trig identities.
Like kind of flip the fraction too. Like would it be 5?
No, can't flip the fraction because it's still 1/5 times that other stuff.
Could be that over 5. Or what about if it was negative 5x?
Say that again.
Just like to the negative 1 exponent, not above it.
Oh, they might write it like that. I would be surprised if they would leave an answer with a negative exponent because it's technically unsimplified, but they potentially could do that. Yeah. Okay, let's try number 8. How do I do number 8? Who's got an idea? You look at that, does that look familiar to you? Okay, so when you see a fraction, what 2 rules are you going to try? 14 and u substitution. We're going to start with thinking about 14. Okay, I'm not going to write this down this time. I'm going to think about it. Okay, so if it's in rule number 14, I take the bottom, which is tangent, and I derive it, and I'm going to see if that's the top. So what is the derivative of tangent? Secant squared. So it is the top. Okay, so I can just go straight to a rule number 14. You wrote that down?
Yep.
I don't even need any steps on this. Okay, what is my integral?
1.
What?
Natural log.
Natural log, remember? Rule number 14 is a natural log. The natural log of the absolute value of the u, and the u is the bottom. There you go.
1.
Let's see. By the way, there was a question just like this on the test that a lot of people missed.
So before you took the correct, you know all of this.
Yes. I did go over it before I took the test because there's a lot of trig on it. Yep. So are we good? Turn the page. Number 9. All right. So number 9, this is kind of an interesting idea. This is where I was trying to pull this one from. I knew it sounded familiar. So, is there a rule for the integral of tangent squared? Is there a rule for tangent? Yeah, so I could potentially do a chain rule and integrate my tangent with that rule. Or I could use a Pythagorean identity. So this is kind of an interesting idea. It is not a necessary idea, but it makes it really simple. Okay, so if we have a tangent squared, and you know this Pythagorean identity, tangent squared plus 1 is equal to secant squared. You did learn that last year in pre-calculus. Whether or not you remember it or not is amazing. So if you were going to take that identity and solve for tangent squared, what would tangent squared be equal to? Secant squared minus 1, right? So I can say that this is equal to secant squared minus 1. And then I can just integrate that. So what is the integral of secant squared?
Tangent.
Tangent. Boom.
Tangent minus
Tangent of x. What's the integral of 1?
X.
X. And then plus c. Okay, so that turned really simple just by doing it that way. We could have done the general power rule and done it that way. That was a little easier. All right, so example 10, this is the last one. So this is the type of question you would see on the AP test. This is the putting it all together. You're finding the area of the region. We did this before, but this time they're using 2 trig functions to do this. Okay, so let's start by drawing this. I think that this is not too hard. If I have y equals 2 cosines of x, what is my amplitude? 2. So if I'm drawing a cosine of x, I start at the amplitude. Okay, guys, I got like 5 minutes. Let's put our phones away. Maybe less. There you go. Okay, so cosine starts at the top and comes down, right? So it'd start at 2, and then it would cross right at pi over 2. So it would look like this in this little frame. Okay, if I was going to draw, hey, 1/2 times the tangent, okay, what does tangent functions look like? John Travolta's, they usually cross through the origin. Okay, the 1/2 would just affect the steepness of him, so he'd be a little bit flatter than normal. So I'm just going to see the right arm of him right here. That wasn't a great drawing. There you go. That actually looks pretty good. Okay, and then it also says it's bounded by x equals 0, so what's x equals 0? The y-axis, basically. Okay, so we're looking at that little area. Okay, so if that's my area, how do I set up my integral?
Oh, that's the volume.
Not volume, just area.
Oh, area.
Top minus bottom. Okay, so you go from the lowest x value. What's the lowest x value? 0. Shh. What's my highest x value? Are you sure? Are they intersecting at pi over 2? Oh, so how do I figure out where these 2 functions are intersecting at? You get the calculator out and you set them equal to each other. Absolutely. So we need to set these 2 equal to each other. So 2 cosines of x is equal to 1/2 the tangent of x. You guys all know how to type that in, yes? I'll tell you what it is. But I would use, just so you know, I did that with my Inspire and I typed it in as a solve. You could graph it with that one, absolutely. With the solve? Yeah, that could have been it. Yes, you should be in radians. But that could be a minute. On that, it's in document. Document? I'll show you here in a second. What? Like off the, when you first turn it on, before you go into the calculate screen or the graphing screen, there's 5 options, and you're going to do document settings. What? You got 4 x values? Oh, what about just before pi? It probably does intersect at many spots.
Mine are like negative 42, negative 41, negative 5.
Oh, okay. I'll go and look at that with you. So what do? I'm not done here. Top minus bottom, right? So the top one is the green. So I have 2 cosines of x minus 1/2 tangents of x dx. So that's the correct setup. By the way, there was a couple on your test that you set this up. Many people forgot the dx. Such a tiny detail, but worth points. Okay, don't forget that.
What chapter?
I was gonna say 6, but maybe 5. I don't know. Oh. So if you type that literally in and do an integral on that, you should get, and you can type this into your 84. Just make sure your mode is in radians again. What's that? Yeah, integral, yeah. Oh, then they lied to you.
Just kidding.
You got 1 through 20.
It's only 20 problems.
It's only 20 problems.